Today we are going to learn about detecting bias in machine learning models. We will explore techniques to identify and mitigate bias, ensuring fairness in AI applications. Welcome to our video on detecting bias in machine learning models. As artificial intelligence becomes increasingly involved in critical decision-making processes, ensuring that these systems are fair and unbiased is crucial. In this video, we'll cover the techniques needed to identify and mitigate bias in your models, helping you create more equitable AI systems. By the end of this session, you'll understand how to assess and address bias using practical, hands-on techniques. Let's dive into the fascinating world of bias detection in machine learning. Bias in machine learning can stem from various sources, including data, algorithms, and societal influences. Data bias occurs when the training data is not representative of a broader population, leading to skewed model outcomes. Algorithmic bias happens when the model itself favors certain outcomes, often due to the design or parameters set by developers. Societal bias stems from existing inequities in society that are inadvertently encoded into AI systems. The consequences of bias in AI can be severe, ranging from unfair hiring practices to biased loan approvals. Thus, understanding and addressing these biases is essential for creating fair and equitable AI systems. Consider the case of an AI system used for predictive policing that disproportionately targets certain communities due to biased historical data. This highlights the importance of fairness in AI and the need for vigilant bias detection and mitigation.
To identify bias in machine learning models, we must first examine the datasets they're trained on. Dataset bias can arise from various sources, including sampling bias, where the data collected is not representative of the entire population, and measurement bias, where errors in data collection lead to inaccurate representations. These biases can significantly impact model predictions, often resulting in unfair or skewed outcomes. Techniques to identify data bias include statistical analysis of demographic distribution, visualizations comparing training and target populations, and examining the data collection process for underlying biases. For instance, in healthcare, biased datasets can lead to models that incorrectly predict health outcomes based on race or gender, as seen in some predictive health models that have been found to disproportionately disadvantage minority groups. Addressing such biases requires a comprehensive understanding of the dataset and its potential limitations. Statistical tools play a crucial role in detecting bias in model predictions. By applying these tools, we can quantitatively assess whether a model treats different groups fairly. Common statistical measures include the chi-square test, which can determine if there is a significant difference between expected and observed outcomes for different demographic groups, and t-tests, which compare the means of two groups to identify disparities. Understanding and interpreting these statistical measures help in identifying bias predictions and taking corrective actions. For example, in loan approval models, statistical tools can reveal whether certain groups are unfairly denied loans based on biased predictions. By thoroughly analyzing the data, you can identify and address these disparities, leading to fairer AI systems. Such statistical analyses serve as a foundation for developing models that are both accurate and equitable.
The confusion matrix is a powerful tool for evaluating the fairness of machine learning models. It provides insights into how a model's predictions align with actual outcomes, allowing us to calculate metrics such as accuracy, precision, recall, and F1 score. These metrics help identify discrepancies in model performance across different demographic groups. For fairness evaluation, metrics like equal opportunity, which measures the true positive rates across groups, and equalized odds, which considers both true positive and false positive rates, are crucial. Consider a hiring algorithm where fairness metrics reveal that the model has a higher false negative rate for female applicants. This indicates potential bias, as equally qualified candidates are being overlooked. By using the confusion matrix and related metrics, we can identify such biases and work towards creating more equitable AI systems. These tools are essential for practitioners aiming to ensure fairness in their machine learning models. Resampling is a common technique used to mitigate bias in machine learning models. It involves adjusting the training dataset to ensure a balanced representation of different groups. Oversampling involves duplicating samples from underrepresented groups, while undersampling involves reducing samples from overrepresented groups. These techniques help in creating a balanced dataset, reducing bias in model predictions. However, resampling comes with challenges, such as overfitting in the case of oversampling or loss of information with undersampling. Despite these limitations, resampling is widely used in various applications, such as credit scoring, where it helps ensure that models do not unfairly favor or disadvantage certain demographic groups. By carefully applying resampling techniques, practitioners can develop more equitable AI systems that provide fair outcomes for all users.
Incorporating fairness constraints into model training is a proactive approach to ensuring equitable AI systems. Fairness constraints involve setting specific criteria that the model must satisfy, such as equal opportunity or demographic parity, during the training process. This requires balancing the trade-off between accuracy and fairness, as strict constraints may affect model performance. Techniques for implementing fairness constraints include adversarial training, which uses an auxiliary model to enforce fairness, and regularization methods that incorporate fairness metrics into the loss function. For instance, in facial recognition systems, fairness constraints can help ensure that the model performs equally well across different demographic groups, reducing bias in real-world applications. While incorporating these constraints can be challenging, it ultimately leads to more equitable and trustworthy AI systems, aligning with ethical AI development practices. Open source tools provide valuable resources for detecting and analyzing bias in machine learning models. These tools offer a range of features that simplify the process of identifying and mitigating bias, making them accessible to practitioners at all levels. Some popular open source tools include IBM's AI Fairness 360, which provides algorithms and metrics for bias detection, and Google's Fairness Indicators, designed to evaluate fairness in machine learning models. These tools offer benefits such as transparency, community support, and the ability to customize solutions to specific needs. By leveraging open source tools, practitioners can efficiently assess their models for bias and implement effective mitigation strategies. Getting started with these tools typically involves integrating them into the machine learning pipeline and using the provided metrics and algorithms to evaluate model fairness. Open source tools empower developers to create more equitable AI systems by providing the necessary resources and support for bias detection and analysis.
Real-world case studies highlight the significant impact of bias in AI systems and underscore the importance of proactive bias detection and mitigation. One well-known case is the use of biased AI systems in the criminal justice system, where predictive policing algorithms have disproportionately targeted minority communities, leading to unfair treatment and perpetuating systemic inequalities. Another example involves bias in hiring algorithms, where AI systems have been found to favor certain demographics over others, leading to discriminatory hiring practices. These case studies provide valuable lessons on the importance of transparent data collection, rigorous bias testing, and ongoing monitoring of AI systems. By analyzing these examples, we can identify best practices for bias mitigation, such as involving diverse teams in AI development and continuously evaluating model performance across demographic groups. Future directions for bias mitigation include developing more advanced techniques for fairness evaluation and fostering collaboration between policymakers, researchers, and industry leaders to create equitable AI systems that serve all members of society. As we conclude our exploration of detecting bias in machine learning models, let's recap the key techniques we've covered: understanding bias sources, using statistical tools, evaluating fairness with metrics, implementing mitigation strategies, and leveraging open source tools. Ensuring fairness in AI is not just a technical challenge but a moral imperative, as these systems increasingly influence critical aspects of our lives. We encourage you to apply the skills learned today in your projects and strive for ethical AI development. To continue your learning journey, explore resources such as academic papers, online courses, and community forums dedicated to AI ethics. Remember, as AI practitioners, we have the responsibility to create systems that promote fairness and equity. Thank you for joining us on this important topic, and we look forward to seeing the positive impact you'll make in the world of AI.